In today's topic of nuclear physics, we are going to discuss the radioactive decays. In core, we are going to discuss that radioactive decay is a change in an unstable nucleus that can result in the emission of alpha, beta, and gamma radiations. And know that these changes are spontaneous and random. State that during the alpha and beta decay, the nucleus changes to that of the different element. In supplement topic, we are going to discuss that the isotopes of an element may be radioactive due to an excess of neutrons in the nucleus and the nucleus being too heavy. Describe the effect of alpha, beta and gamma emissions on the nucleus, including an increase in the stability and a reduction in the number of excess neutrons. The following changes in the nucleus occur during a beta decay. Neutron changes to proton plus electron, and in use decay equation using nuclide notation to show the emission of alpha, beta and gamma radiation. Okay, we know that alpha and beta are the particles and the gamma are the radiation. Alpha are the helium nuclei which contain 2 proton and 2 neutron, while electron are the electrons, and these electrons, when we said about the beta particle, these are the electron emitted from the nucleus of an atom, and the gamma are the radiation, electromagnetic radiation. When a nucleus have enough energy, they release the energy in the form of gamma radiation. Okay, the most stable nuclei have roughly the same number of proton to neutron. Okay, the atom consists of a nucleus in which we have protons and neutrons. In the nucleus, we have protons and neutrons, and electrons revolve around the circle in circular orbits. Okay, but we are going to discuss the nucleus, and the stable nuclei are those which have proton number equal to neutron number. If there are difference in the proton number and the neutron number, if the proton number are too high, the repulsive force between them is very large, because we know that positive and positive repel each other. So the repulsive force is very high if the proton number is high. Therefore, if a nucleus has an imbalance of proton and neutron, it is more likely to decay into small nuclei until it gets to a stable nucleus with roughly the same number of each. And we have seen that when a uranium decay, it form thorium and barium. But this decay is not a radioactive decay, because we have bombarded uranium with the nucleus. If uranium on their own decay, giving alpha particle, beta particle or gamma radiation, then that would be a radioactive decay. When a nucleus break down, a nucleus we do not have equal number of proton and neutron, it break down into smaller nuclei to get a stable nucleus with roughly the same number of proton and neutron. Therefore, isotopes of an element may be radioactivity due to excess of neutrons in the nucleus being too heavy. Okay, if the nucleus is too heavy, that it means that it has too many protons and neutrons. The force in the nucleus will be weaker in keeping the proton and neutron together. This can cause the nucleus to decay. As the electrostatic force of repulsion increases, there is more chances that a nucleus will going to decay. For example, uranium-238, which is used in nuclear fission reaction, as I have tell you earlier, this nucleus has 238 proton and neutrons. There are large number of proton and neutron are present in it. So uranium-238 generally reduces the mass number of the element which is decay into. This is done through alpha decay or the beta decay. Okay. During the alpha or the beta decay, the nucleus changes to different element. The nucleus changes to different element. Why it changes to different element? I will tell you in a few bits. The initial nucleus is often called as parent nucleus, and the nucleus of the new element is often called as daughter nuclei. Daughter nucleus or nuclei if they have more than one nucleus. Okay, in the alpha decay in which we get helium 42. For example, we have a compound X with the atomic mass A and the atomic number Z. Decay. What is going to happen? Its atomic mass decreases by 4 and atomic number decreases by 2. Now we can see that its atomic number changes. The parent nuclei has atomic number Z and the daughter nucleus have atomic number Z minus 2. An element is known by its atomic number. So if the atomic number changes, it means that it is not the same element now. It changes to some different element. Same for the case of beta, in which we will get an electron. Okay. In beta, for example, we have XAZ, a parent nuclei, which is going to decay with the beta decay, beta 0 and minus 1. In this case, our atomic number, atomic mass remain the same. Atomic mass remain the same, but the atomic number increases by 1. How this is going to happen? In this case, when we got a beta decay, our neutron decay to form a proton and an electron. That electron is our beta particle, and our atomic mass remains same because a neutron decay to form a proton. A neutron number decay and a proton number increases. That's why our atomic number remain the same, but our proton number or the atomic number increases. Mass number remain the same, atomic number increases by 1. So when the atomic number changes, the element changes. So during a beta and the alpha decay, the proton number, atomic number changes, so the nucleus changes to different element. Okay, the third one, the isotopes of an element may be radioactive due to excess of neutron in the nucleus or the nucleus being too heavy. Therefore, if a nucleus has an imbalance of proton or neutron, which means that the proton number is not equal to neutron number, it is more likely to decay into small nuclei until it gets to a stable nucleus with roughly the same number of each. If a nucleus is too heavy, like we have seen in uranium-238, which is very heavy nuclei because it has very large number of proton and neutron. That's why the force of repulsion between protons become very large than the binding force. Binding force is the force that keep them together. So when that force, the repulsive force increases, the nucleus will going to decay. Okay, now the alpha decay. In alpha decay, 2 neutron and 2 proton are released from the nucleus, due to which the number of nucleons decreases and stability increases. In the same way, in the beta decay, a neutron is converted into proton and electron. So neutron number decreases and proton number increases and may become equal to each other. So the stability increases. Those elements whose have proton number equal to their neutron number are more stable than those which have different between the proton and the neutron number. Okay, these are the decay equations. We have discussed these in our previous lecture also. Okay, when an atom decays with the alpha particle, its atomic mass decreases by 4, atomic number decreases by 2 with the release of the alpha particle, which is also known as helium nuclei. Helium nuclei. In the beta particle, our atomic number remains same. Our mass number remains same, atomic mass remains same, or our proton number or the atomic number increases by 1. Increases by 1 because our neutron decay into proton and electron. This electron is known as beta particle. In gamma radiations, our atomic mass and the atomic number both remain same. Gamma radiations are just the excess energy that a nucleus has released in the form of electromagnetic radiations. Okay, question. A radioactive nucleus emits either an alpha particle or beta particle. What are the product of these two types of radioactive emission? Product after alpha emission, a nucleus of different element. Product after beta emission, a nucleus of different element. Okay, so we can see that from the equation, the first option is the right option because In both alpha and beta, the nucleus of different element are formed because they in both cases atomic number changes. In both cases atomic number changes. Okay, see you in next lecture with the topic half-life.